Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0115 indicates an issue with the Engine Coolant Temperature Sensor 1 in the Honda Accord 2023 model. This code signifies that the output voltage from this sensor is outside the specified operational range, prompting the Powertrain Control Module, PCM, to recognize an abnormality. The ECT sensor plays a significant role in the engine's cooling system by monitoring coolant temperature, which is crucial for optimal engine performance and emissions control. It provides temperature data to the PCM, allowing for timely engine adjustments. If the sensor malfunctions or produces readings outside the defined voltage range, it can lead to improper engine operations, increased emissions, or potential engine overheating. The sensor is typically located near the engine block, attached to the coolant passage. Proper functionality of this sensor is essential for the accurate operation of the engine management system. The error code P0115 refers to an abnormal voltage output from the Engine Coolant Temperature Sensor 1, indicating that its readings are outside the acceptable range. The PCM, or Powertrain Control Module, is designed to monitor this voltage and alert the driver to any discrepancies. If the ECT sensor's output is lower than 0.16 volts or higher than 4.92 volts, the PCM registers a fault, prompting the error code P0115 to be stored. The ECT sensor plays a critical role in assessing the engine coolant temperature, which is vital for engine efficiency and operational performance. Positioned near the engine's coolant passage, the ECT sensor helps regulate engine temperature by relaying information to the PCM, enabling it to adjust fuel mixture and emission settings as required. Therefore, when this sensor fails or experiences output anomalies, it can adversely affect the engine's performance and overall vehicle efficiency. Several factors may contribute to the triggering of the DTC P0115. The primary suspect is a faulty ECT sensor 1, which might not be providing accurate readings, resulting in voltage deviations. Another potential cause could be issues in the external circuit that facilitates communication between the ECT sensor and the PCM, which includes wires and connections that might be damaged or improperly connected. Additionally, if both the sensor and its corresponding external circuit are functioning normally, a malfunction within the PCM itself could be the source of the issue. The PCM serves as the vehicle's brain, interpreting signals from various sensors, including the ECT sensor, and any failure in this unit may lead to further complications. To effectively address the situation, each of these components should be thoroughly inspected to isolate and rectify the underlying issue. The presence of DTC P0115 can manifest several notable symptoms that may indicate an underlying issue. Engine overheating is one of the primary warning signs, as an inaccurate reading from the ECT sensor can lead to improper cooling system management. Additionally, drivers may notice a decline in fuel efficiency as the PCM takes action based on faulty temperature data, negatively impacting fuel mixture calculations. Furthermore, inconsistencies in engine performance can also arise, leading to erratic behavior during operation, such as stalling or difficulty maintaining speed. Dashboard warning lights might also activate, alerting the driver to the issue. Monitoring these symptoms is crucial, as they can signify both immediate and long-term risks to the vehicle's health and performance. The first step in troubleshooting the P0115 code involves checking the operation of the Engine Coolant Temperature ECT Sensor 1. Begin by turning the vehicle ignition to the on mode, which powers up the vehicle systems without starting the engine. Using the Honda Diagnostic System, HDS, Observe the voltage reading for the ECT Sensor 1. A significant marker here is when the voltage measurement is either less than 0.16 volts or greater than 4.92 volts. If either condition is met, this indicates an abnormality, which further confirms the existence of the fault within the ECT sensor or associated circuits. Conducting this step provides an essential baseline diagnostic value that informs further action in the troubleshooting process. The second step in troubleshooting involves a direct examination of the ECT sensor itself. First, ensure the ECT Sensor 1 connector is disconnected, isolating the sensor from the circuit. Utilize a jumper wire to connect terminals number 1 and number 2 within the disconnected ECT Sensor 1 connector. This action simulates normal operation conditions. Next, turn the vehicle to the on mode again and check the HDS for the ECT Sensor 1 voltage reading. A normal result, in this case, would be a value that falls below 4.92 volts. If the measured voltage aligns with this standard, it suggests that there may be a fault within the ECT sensor itself. Conversely, if readings are abnormal, it indicates that the problem lies within the external circuitry or the PCM rather than the sensor. Moving on to the third troubleshooting step, ensure that both the ECT Sensor 1 connector and the PCM Powertrain Control Module Connector B are disconnected. This inspection will focus on the integrity of the signal wires, specifically the TW, temperature wire, and SG2 ground wire. To begin, inspect the wiring for continuity and confirm that the TW wire has less than 1 ohm of resistance when tested for open wiring conditions. And similarly, the SG2 wire should also show less than 1 ohm. If any of these checks show abnormal resistance, it indicates a possible circuit fault, which must be resolved before proceeding with further diagnostics. Furthermore, refer to the open shorted wire inspection description to check for short circuits, particularly if the TW wire appears grounded. The finale of the troubleshooting steps involves confirming the status of the PCM. If the previous inspections of the ECT Sensor 1 and external circuit returned normal operating conditions, this increasingly points to the PCM itself as the root cause of the DTC P0115 code. The PCM is critical, interpreting signals from various sensors, including the ECT sensor, and any malfunction here can lead to further erroneous readings and vehicle performance issues. Test the PCM's functionality to ensure it can process inputs correctly. If it fails this inspection, then replacement or reprogramming of the PCM may be necessary to resolve the P0115 error permanently. After completing the necessary repairs based on the diagnostic findings, it's critical to verify that the DTC P0115 has been resolved effectively. Start by clearing the DTC from the vehicle's onboard systems using the Honda Diagnostic System, HDS. Following this, conduct a test drive to ensure that the vehicle operates normally without recurring issues. Watch for any warnings on the dashboard and monitor the performance, particularly the engine cooling system functions. It's paramount to confirm that the ECT sensor accurately relays temperature data post-repair. A successful resolution will entail no error codes reappearing and a return to expected engine performance, indicating that the issue has been adequately addressed. Preventive maintenance plays a crucial role in avoiding issues like DTC P0115 in the future. Regular inspection of the engine cooling system is essential to ensure that all components, including the ECT sensor, are functioning properly. Keeping a close eye on the ECT sensor can help identify early signs of wear or malfunction, thus preventing unexpected failures. Additionally, maintaining the integrity of the electrical connectors and wiring associated with the ECT sensor and PCM is vital. Ensure they are clean and free of corrosion or damage. Adopting these preventive measures can enhance the lifespan of the components involved, promote efficient system performance, and ultimately prevent costly repairs. In conclusion, diagnosing and addressing DTC P0115 is vital for maintaining the overall health of the Honda Accord 2023 model. The engine coolant temperature sensor serves an essential role in ensuring engine efficiency, and a failure in this component can lead to significant operational issues. Thorough troubleshooting methods enable technicians to isolate and rectify the malfunctioning parts, ensuring that the vehicle performs optimally. Additionally, understanding the importance of preventive maintenance practices can significantly reduce the likelihood of encountering similar issues in the future. Maintaining a proactive approach towards vehicle care not only enhances performance, but also ensures prolonged reliability and safety while driving. Please like and subscribe to the channel. See you next time.